Welcome back to Learn Orbit Tech Academy. In our last episode, we looked at the structural skeleton of a PL/SQL block. Today, we are zooming into the microscopic level, the absolute DNA of the language. We will unlock lexical units and master the core data type engine. If you are a beginner writing your first declaration or a senior developer, hope this breakdown gives you a clear advantage. Let's dive straight in. Just like human languages, PL/SQL use letters, numbers, and grammar rules to form sentences and relies US7A ASCII set consisting of letters, digits, basic symbols, and white spaces. When a compiler reads these characters, it groups them into four atomic building blocks called lexical units. That is, identifiers, literals, delimiters, and comments. Let's break down each one. First is identifiers. Naming your entities. An identifier is simply a text name tag given to a database object like a variable, package, or subprogram. Think of it as your name. It identifies who you are but doesn't define your weight or height. To keep our code valid, our identifiers must follow four strict rules. These are the rules mentioned on the screen. Note that PL/SQL is naturally case insensitive. Identifiers are divided into three different buckets: a reserved words and keywords, that is, identifiers with native hard coded meaning like declare, begin, or if, we cannot use them as our own variable names. If we wrap them in double quotes, it overrides the keyword and transforms it into a case sensitive, but it is highly discouraged for its readability. Second is predefined identifiers. Identifiers globally exposed by Oracle via the system standard package, such as the standard exception invalid number. We can view the list of predefined identifiers at any time using the query given on the screen. Third is user defined identifiers, the custom names we create for our own local variables and constants. Here is an example. We have written a code here. As we have learned that set server output on is must to print our message on the console. V underscore employee salary is a valid variable name because it starts with letter. It fulfills the rules that should be followed for a variable name. Another is also valid because it contains authorized symbols. But the third one is not valid because any variable name cannot be started with a digit. Next is also not valid because it contains illegal white space. Now here we have used keyword in the double quotes and we will test it whether it prints the value or not. It is printing, but the usage is very dangerous. We must avoid this kind of keyword usage as a variables. Next come literals. Literal is an explicit raw value that cannot be calculated from other variables. PL/SQL code is case insensitive, but character literals are strictly case sensitive. To the PL/SQL engine, capital Z and small z are entirely different values. PL/SQL has no line continuation character, so if we want a text literal to span multiple lines cleanly, we must wrap it using the string concatenation operator. Here we have tried the block with the concatenation operator and let's see what it prints. It prints the line in a one single line. Next comes delimiter and comments. Delimiters are individual characters or compound character, mathematical operator that signify structural operations. And comments are completely ignored by the database precompiler engine, making them perfect tool for code maintainability, debugging, or temporarily isolating faulty lines during testing. Please don't use multi-line comments, nested multi-line comments, because doing so will immediately break our compilation code. Now we move on for the data types. We have learned about identifier and variables, and now we will learn how every variable must have a assigned data type. This data type serves as strict rules on what values are allowed and what operations can be performed using these variables. PL SQL natively adopts all standard SQL data types as shown in the table here on the screen, but their structural memory size allocation behave differently depending on whether they are running from a procedural part or from a database table. Notice here that Varchar 2 can scale up to 32,767 bytes within a procedural variable memory, but it drops to strict 4,000 byte cap when stored in a database column. If a variable holds a value larger than its defined data type, a runtime error is instantly thrown. For large legacy fields, keep in mind that long or long row variable can only process up to 32,760 bytes in the code memory. Next comes the high precision floats, binary float or simple float. For scientific calculation, Oracle provide binary float and binary double. But if you want to bypass the performance overhead of null checking, we can use simple float and simple double subtypes. They share identical numerical range but enforce a strict not null constraint. Here we have written a code using a simple double data type. Let's check what it prints. The value is printed in this format. Next comes the Boolean paradox. The Boolean type handles three states: true, false, and null. Crucial note for interview. In Oracle SQL, an empty string is not processed identically to a literal null. Null represents unknown or absence of data, and it don't store any memory. But empty string stores memory, and it means it is an empty string. Further, we cannot directly pass a Boolean variable into a DBMS output.put underscore line unless we configure the compiler session to allow implicit conversions or evaluate the state explicitly. Let's check what happens when we define a variable with a Boolean data type and print it in the DBMS output.put underscore line. We get an error that wrong number or type of argument in call to this. It means Boolean value cannot be printed. Next comes JSON data type. Modern applications rely heavily on JSON. PL SQL processes native JSON type in a highly optimized binary format. We can use JSON data type across table DDL, subprogram input, local record, collection element, and row type schemas. But JSON objects are not currently supported inside legacy SQL collection objects. We can use the JSON in this way in the PL SQL block. Next comes database address maps, row ID and UID. Every row in your database has a physical location address called a row ID. To load a binary row pointer into a text variable, we use explicit formatting functions like row ID to char and char to row ID. And if invalid address pattern is passed, the engine will stop execution and raise a sys invalid row ID error. As seen here, we have created a PL SQL anonymous block. We have selected the row from table help and we are trying to print the address where this particular row or value is stored. Let's check the output. This is the address printed for this particular value. This is not the value of the row with this sequence ID of the table. This is the address, memory location where this value is stored. Lastly, there comes PLS integer data type. For our experienced developers to optimize loops and counters, swap traditional number reference to PLS integer or binary integer because they are completely identical but store signed integer ranging from roughly -2 billion to +2 billion using 32 bits of space. Number logic relies on software library arithmetic, but PLS integer runs directly on your database server internal hardware, so it requires less storage and runs faster. There are two built-in subtypes like natural or positive for non-negative number. For constraint efficiency without overflow checking, use simple integer which enforces a native not null constraint. We can declare these variable with these data types in this format. Now comes user defined subtypes. We can create our own custom domain rules using user defined subtypes. There are two variations. Unstring subtypes that gives an alternate structural alias to an existing base type. Just as a personal nickname, the person remains the same but the name can be different. And another is constrained subtype. This limits the base type down to tight explicit subset of valid ranges or precision attributes. The engine will only allow conversion into this subtype if the value doesn't violate the boundary rule. Here we have written the PLSQL block. We have defined subtype of customer name with data type varchar2 having 10 precision. Another is the subtype priority rating with PLS integer data type, but its range is limited from 1 to 5 and it should not be null. This is known as constrained subtype. This is an unconstrained subtype. Now we defined a vBuyer variable of customer name subtype and assigned a value to it. Next is vRank variable with priority rating subtype and assigned a value which is valid within the range. But I have also defined a variable with the priority rating where value is assigned 10 and it is out of this range. Let us try what is the output. We got a value numeric or value error because the value 10 is not within the range mentioned. From this, it is clear that constraint subtype are imposing rule and constraint on the variable. Now we comment it out and see the output, and our block has run successfully. These lexical structures, knowledge, and practice ensures our backend application handle real-world scale without unexpected crashes. If today's tutorial cleared up these architectural concepts for you, give this video a thumbs up, drop your questions in the comments below, and don't forget to subscribe to Learn Orbit Tech Academy. See you in the next video.